So in this lecture I will be solving 4 numericals related to synchronous machine, and this is a can consider this as a first tutorial, and I will be preparing some more tutorial as time goes. But this tutorial has been prepared by me, and this is for only theoretical consideration, while it don't relate to any practical synchronous machine. At the same time, what I have considered are valid for the ideal conditions of operation. Also steady state operation. So the first question is, for a synchronous machine whose frequency is equal to 50 Hz, this is given, and the question is to find 3 possible combination of pole pair and synchronous speed. So only the frequency is given. So based on the frequency, it's possible to get the equation of the synchronous speed, which is given by P into Ns divided by 120. This is the equation of synchronous speed for synchronous machine or generator. So if you are substituting it, what you will get is, you will get P into Ns is equal to 6000, which is my RPM. And now based on the poles which you have, like if you have 2 pole machine or a 4 pole machine and a 6 pole machine, it's possible to substitute the P here. So we will get Ns is equal to 6000 divided by 2, and Ns is equal to 6000 divided by 4, and Ns is equal to 6000 divided by 6, which gives speed of 3000 RPM and 1500 RPM and 1000 RPM respectively. So this was the first question, and if based on the frequency, it's possible while you're designing the machine, or if a question is given in which only the frequency is given or the synchronous speed is given, or both the poles and the synchronous speed is given, then it's possible to calculate the frequency based on this. Next is a kind of question where again the assumptions for the previous questions are valid. This is only for theoretical purpose, and if you are considering a machine which is having a 6 poles, it is 3 phase, and now this machine has 72 slots for stator, and this is a distributed winding for stator. Now the question is to find KD, or distribution factor, also known as KB breadth factor. The formula for KB or KD is equal to sine m alpha by 2 divided by m sine of alpha by 2, where alpha is equal to, or where m alpha is equal to my phase spread. So the first question is to calculate what is your M, which can be given by slots per pole per phase, which is equal to 42 divided by the number of poles is 6 and the phases are 3, which is equal to 4. So this is what is your M, and your M of alpha, which is equal to your phase spread. So your alpha is given by what is 180 degree, or pi divided by M into Q, which is equal to 180 degree by 4 into my Q is equal to my poles divided by phase, which is equal to 3. This alpha can also be given by the equation of 5p divided by s. So what is alpha is equal to 180 into the number of poles is equal to 6 divided by slots is equal to 72. So that will give me 180 into 6 divided by 72, which is equal to 15 degree. So my phase spread is equal to, so substituting in the equation, KD is equal to sine of the phase spread, which is equal to 4 into 15 divided by 2 divided by sine of, or M is equal to 4 sine of alpha by 2, where my alpha is 15 by 2, which is equal to 7.5, which is equal to my KD is equal to 0.5 divided by 4 into sine of 7.5, which gives my KD is equal to 0.957. So this is what is my distribution factor, and this is how to calculate it if it is given in a specific problem way in which it is given with the details which right now I have mentioned. So again the next question is, there is for the same machine there is a 6 slot 3 phase synchronous machine or generator with 72 is the slots, and the KD which was calculated is equal to 0.958, and the pitch factor is equal to 1, that is the windings are full pitched. Now the conductors per slot is equal to 10, and flux per pole is equal to 0.04 Weber per pole. Now the question is to find out the question is to find out what is my. So based on this is again a theoretical question only. So the question is to find out the RMS value of EMF. So again this is theoretical question only with no relation to any practical synchronous generator, only to demonstrate the calculation possible, also considering ideal case. So if you have such a question, then your Z is equal to 10 and your total conductors Z is equal to 10 into number of slots, which gives you close to 720 conductors. Now if you want to calculate Z per phase, then it will be 720 divided by 3 into 2 will give you what is your turns per phase, which comes out close to 120 turns per phase is equal to my T, and my equation for the EMF of RMS per phase is equal to 4.44 into F into phi into T into KD into KW or KP, pitch factor. So based on this my frequency can be calculated, which is equal to Pn divided by 120, which is equal to 6 into the RPM. So the RPM n is equal to 375 RPM. That is equal to the synchronous speed of this machine. So do 375 divided by 120. So it is equal to 6 into 375 divided by 120, which comes close to, or which is equal to, so there is just, my number of poles is equal to 6 for this, if you have noticed a mistake here, and my speed which I am considering for this machine is 1000 RPM. So based on this speed of 1000 RPM is my synchronous speed. Based on this speed I will get a frequency of 50 Hertz. So this is my first calculation, and putting all the values, 4.44 into 50 into flux, which is 0.04, into my turns, which is 120, into KD which is equal to 0.958, and Kp which is equal to 1. So this will give me what is 4.44 into 50 into 0.04 into 120 into 0.958 into 1, which is equal to 1020.8 volts. This is my ERMS for this synchronous generator. So again, taking one more question, if my question 4 is for the same generator and with the same consideration, same generator, but now if there is a change, my generator is a 6-pole machine, it is synchronous, then again it is 3-phase machine. Now it is having 72 slots, and there is 12 slots per pole for this machine. So I am making some changes, but the parameters are almost same, and to find out the pitch factor, now the coil span is equal to the 1 minus 10, where 1 is my first start of the coil and 10 is my end of the coil. So this is start and this is end. So my coil span is equal to 9 slots. So this falls. So my question is, so these are the details which are given. So all these values are given. Now the question is to find out kph, or pitch factor. So based on my coil span gamma, if I'm considering my gamma is equal to my coil span is equal to 9 slots, and how much my slots will, if I'm considering C is equal to 3 slots, this is the amount by which my which is my slots fall short. So calculate my beta, which is equal to the angle of the pitch factor, can be given by angle by which it is short pitched, can be given by beta is equal to 180 degree into the number of slots which are been falling short. So per pole the short slots should be 12, but it is falling short by 3. So again divided by the number of slots will give me a beta of close to 45 degrees. And now my kph is equal to cos beta by 2, which is equal to cos of 45 degree by 2. Zero 0.9238. This is my pitch factor. And again, for when if I'm adding something to the question, as to find kph for third harmonics. These are my two unknowns, so again I'm adding one more parameter. So kph for the third harmonic, which will be equal to cos of whatever I am considering. So it is cos of 3 into beta by 2, which is equal to cos of 3 into 45 divided by 2, which comes up to what is 0.382.